This is a complicated question because it has not only time but distance. So I need to make several drawings. So let's have this be our point P where the man is starting, and we're going to call this Q where the woman starts walking, and this is a constant of 500 feet between the two. So when t equals 0, this is what we have. We have a man standing here, and he's just getting ready to start walking. Now, everything here is in feet per second, so we need to change all our minutes to seconds. So right here, we'll take and we'll put P here, and we'll put Q here. Sorry, that should be a line. And this is still 500 feet. But the man has begun to walk. So we're going to call this dm for man, dt. That's his rate. He is walking 2 feet per second. So when t is 5 minutes, 5 minutes times 60 seconds per minute, we see that at 5 minutes, the time is actually 300 seconds, and we know where the man is. Let's see if I can draw a line. Oh, I needed to do this. There we go. So after 300 seconds, the man, his distance, he has traveled 2 times 300 is 600 feet. That should be a 0. So here's point P still. And here's point Q. It's still 500 feet away. And this is when the woman starts to walk. Okay. So at this point, this is the distance that is changing. Okay, so this is the distance between the man and the woman. And it's going to be changing. So we'll say d distance dt at a certain rate. And that's what we're looking for, is the change of this distance. But we're not finished with the problem. Okay, so 5 minutes later, the woman starts walking. So let's talk about what we have 5 minutes after that. Okay, so this is the man's distance. This is 500. This is now the woman's distance. So when t equals 10 minutes, 10 times 60 is 600 seconds. The man has gone 2 times 600. The man has gone 1,200 feet. And the woman has gone, remember, she's traveling, we'll call her dw dt. Remember, she's traveling 4 feet per second in the opposite direction. So at 10 minutes, so she started 5 minutes after the man. So she's only gone for 5 minutes, right? The man's been traveling 10 minutes. The woman has only been traveling 5 minutes. So her distance here is, well, 5 minutes is 300 seconds. She's gone this far in 5 minutes. Okay, does that make sense? She started 5 minutes after the man. So at 10 minutes, the man has been walking 10 minutes. The woman has only been walking 5 minutes. So 4 feet per second, 5 minutes is 300 seconds. She travels 1,200. So now this is the distance right here that they are apart. Now, let's look what happens 15 minutes later. Okay, let's get a new board. So now, when the overall time is 15 minutes, that means the man has been traveling the full 15 minutes, which is 15 times 60. That's 900 seconds. But the woman left 5 minutes later, remember? So she's only been traveling 10 minutes, which is 600 seconds. So here we are. Here's the man. Here's the 500 feet between them. Here's the woman. After 15 minutes, the man has gone 900 times 2 is 1,800 feet. The woman in 600 seconds, 4 times 600, has gone 2,400 feet. Okay, so this is P, this is Q, and this is now the distance between them. This is now our distance. Okay. The question says 15 minutes after, a second. After the woman starts walking. So 15 minutes after the woman starts walking is really a total time of 20 minutes. So the man, for the man, that's 20 minutes times 60 seconds a minute. That's 1,200 seconds. The man has been traveling 1,200 seconds. But the woman has only been traveling 15 minutes, and 4 times 15, or 15 minutes times 60 she's been going 900 seconds. Okay, so here's our picture now. Our final picture is the man, the 500, the woman, and 1200 seconds times 2 feet per second. The man has gone 2400 feet. The woman in 900 seconds times 4 feet per second has gone 3600 feet. And now here's the distance between them. And this is the situation when we finish the problem. So we really need to know this distance, and we need to know the rate at which it's changing. Now, I would like to superimpose upon this a right triangle, because this is actually a right triangle problem. If we would make a right triangle here with the distance, I'll leave it pink, and let's call this side A, call this side B, call this side C. We know that A squared plus B squared equals C squared. So when you're doing related rates, that's the formula that we need. So we do implicit differentiation here, and we say 2 times A times dA dt plus 2 times B times dB dt and that's going to equal 2 times C times dC dt, and this is our distance that we want, right? This is our d distance dt. So let's make our lives easier for a moment and divide everything by 2. This 2 goes away, this 2 goes away, this 2 goes away. And what I'm looking for is this, so I'm going to divide all the sides by C. So now I need A, which is actually this 2400 and this 3600, so that adds up to 6000. That's that full side, times dA dt. Now, A is changing. The 2 feet per second up and 4 feet per second down is really a change. It's really spreading apart at 6 feet per second. Okay, then plus B, which is 500, right? That's that distance that between them. And at what rate of change is B, dB dt? Well, that would be 0. It's not changing. And that's all divided by C, our distance. And this is going to equal the answer that we're looking for, the change in the distance between them with respect to time. So we got to figure out, so we need to figure out what C is. And so if we go A squared, remember A here is 6000 because it's both of them, And b here is 500. And so if I go a squared plus b squared equals c squared, which is our distance, then I get that c is the square root of this, which reduces down. So this is, let me get a calculator, 6,000 squared plus 500 squared equals the square root of 3625 and 4 zeros. Okay, so this will reduce. It took a while, but this became 500 times the square root of 145 when it reduced. And that's what's going to go right here. That's C. So this is all over 500 times the square root of 145. So we almost have our answer, because this is 0. Now, let me go down here a little farther. So now I have, this is what we're looking at here, and we're going to reduce it. So 6,000 times 6 is 36,000. Oh my gosh, why is that doing that? Okay, so this becomes 36,000 plus 0 over 500 times the square root of 145. And that reduces to 72 over the square root of 145. And if your teacher wants you to rationalize the denominator, that's fine. But this is the change in the distance between the two with respect to time. So that makes it the units feet per second, right? Distance is feet, and our time is measured in seconds. So here's your answer. I'll put it in red over here. The answer is 72 over the square root of 145 feet per second. And if you want the decimal approximation, it's 5.979. .979 feet per second. And that's the answer that I get. Thank you.